Greetings to everyone. Today we are continuing with the acids and base. The question here says calculate the pH of the solution. So we are going to answer this question. Let's start by looking at the steps that we follow when we calculate whatever asked in this topic. The first thing we said, you must write down the balanced chemical equation. Let me just copy this one as it is. So 2 sodium hydroxide solution reacts with sulfuric acid. Sulfuric acid, I mean not H2O, sulfuric acid with SO4. Then we get the products. Okay. Then the following step says collect the data. When we collect the data, we read the statement first. The statement reads as follows. The sodium hydroxide solution of concentration 0,2. The sodium hydroxide with that concentration 0,2 and the volume of 40 centimeter cube is titrated against the sulfuric acid. Sulfuric acid of concentration 0,1. That is the sulfuric acid, and the volume, which is 25 centimeters. Okay, so we have the sulfuric, the sodium hydroxide, which is 0,2 moles per dm cube. So we have this concentration. Then we're also given the volume. The volume is 40. Then we change it to dm cubes. It should be 0,04 dm cube. That is the volume that we have. Then we are also given the concentration of sulfuric acid and its volume. So the concentration of sulfuric acid is 0,1 mole per dm cube, and its volume is equal to 25 centimeter cube. Then we divide by 1000 to get the dm cubes. That is dm cube. Now step number 2 is done. Let's go to step number 3. Step number 3 says change everything to the number of moles. Now we calculate the number of moles. Number of moles N will be equal to CV, because we are given the concentration and the volume. Now let's substitute. So we have the concentration, which is 0,1 times 0,025. Then we get the number of moles. These are the initial number of moles. Let's press the calculator. 0,0025 moles. These are the initial number of moles. Let's calculate the number of moles of sodium hydroxide. So N is equal to CV. Then the concentration is 0,2 by the volume. The volume is 0,04. Then we get the number of moles. These are the initial number of moles. Then we get 0,008 moles. We are done with step number 3. Let's get to step number 4. Use the mole ratio to get the limiting reactant, because we don't know the limiting reactant in this case. So let's use the mole ratio to get the limiting reactant. How to get the limiting reactant? We use the mole ratio. 2 moles of sodium hydroxide reacts with 1 mole of sulfuric acid. Now let's calculate the number of moles of sodium hydroxide that reacts with 0,0025 moles of sulfuric acid. Then we get the number of moles reacted, or that reacts. We get 0,005 moles. Okay. Then after many number of moles reacted, we calculate the number of moles in excess. Number of moles in excess is equal to number of moles initial minus number of moles reacted. So the number of moles initial, it's 0,008 minus number of moles reacted, 0,005. Then we get 0,003 moles. These are the number of moles in excess. Since the number of moles in excess are positive, therefore this one is in excess. Sodium hydroxide is in excess, meaning that there is no need to calculate the number of moles reacted for sulfuric acid, because sulfuric acid now is the limiting reagent. Okay. Now we are going to use the number of moles that are in excess to get the concentration of a solution. So remember that we pour the 25 cm cube and a 40 cm cube, meaning that the total volume that we have is 65 centimeter cube in that container. Then we divide by 1000, then we get 0,065 dm cube. That is the volume in the container with the number of moles, those number of moles, meaning that we can calculate the concentration of the solution by N over V. Then the number of moles that are in excess is 0,03 divided by the volume, which is 0,065. Then we get the concentration 0,003 divided by 0,065. Then we get the concentration as 0,046 mole per dm cube. That is the concentration for the solution. Then let's go to the question. The question says calculate the pH. Calculate the pH. Calculate the pH of the solution. Calculate the pH. So the formula for the pH says pH is equal to minus minus log concentration of H3O plus. We need the concentration of this one, but this one is the concentration for sodium hydroxide. So we use KOH, concentration of H3O plus times concentration of OH minus is equal to 1 times 10 to the power negative 14. This is the formula from the formula sheet. We are looking for the concentration of H3O plus. OH minus is 0,0 0.46 concentration yakhona, which is 1 times 10 to the power negative 14. Then we divide by 0.046 both sides. Then we get this one. That is concentration of H3O plus, which is equal to it's 1 times 10 to the exponent negative 14 divided by 0.046. Then get the concentration, which is 2173 times 10 to the power negative 16 mole per dm cube. Then we take this and substitute there. Therefore, the pH will be equal to minus log of the concentration, which is 2,17. Oh, it's 217 or 217. Okay. 2173 times 10 to the power negative 16. Then we get the pH. The answer is minus log times that. Then the pH. The pH is 12,6. 12,66. That is the pH we were looking for. We are done. That is like that. And thank you. Let's see the next video. Thank you.